Now we look at some of the again a practical way of problem solving. So I have written down some of my thoughts here. There is nothing more revolutionary, more powerful, more transformative than an idea. All the conflicts in the world going on in the world today and all the wars that are being fought are for freedom, which is nothing but an idea or a concept or a notion. Everyone from the mercenary to the terrorist to the dictator and despot to the patriot to the humble software programmer is always a freedom fighter. The most powerful force in the world is never the tangible weak or the strong nuclear force, but always only the intangible force of the spirit of freedom. All of those other powerful forces only exist to serve this super powerful spiritual force of freedom. All of us heartily agree and concur with the observation that the simple pleasures in life are its bliss. So also in problem solving, the simple ideas tend to be extremely, if not in fact also the most effective ones. We have often heard it said and proclaimed and ourselves joined in the fray in mindlessly parroting the popular opinion and sentiment expressed as the only things that make life worth living, the only thing that gives life its meaning and its purpose, the only things that make a big difference and matter the most in life are the little things, till it sounds like an empty, hollow, vacuous, weary and worn out cliche, offensive to our ears. But it rings very true in the world of causation or the world of cause and effect, which is the same as the world of logical reasoning or the same as the world of problem solving, including for the purposes of computing. Now every implication we know has an antecedent and a consequence. What you must remember is that tiny causes have huge effects that are cascaded effects and ripple effects, and also they tend to accumulate and build up over time and have a snowballing effect. Contrary to popular and common understanding, a single action can have several reactions, several possible effects. Several causes can have a single effect, right? An effect in turn can serve as a cause, and a cause in turn can be an effect. So all of these things happen. So nothing is very simple, overtly simple. So we already know that if we know the value of root 2, we can code enormous amounts of data, because a consequence of the fact that root 2 is infinite is that you can code enormous amounts of data losslessly in very, very small amount of information losslessly, a small amount of data. So this means, right? There are other ways also. For instance, the simplest one is, there are other ways of life, similar only. If you have a number which lies between 2 power I and 2 power I plus 1, you just have to code the value I, right? And 2 power I plus 1, since it can be written as 2 power I plus half plus and so on up to 1 by 2 power, say L minus x or whatever. So this part is nothing but 2 power I into root 2 into 4th root 2 into 8th root 2 into 1 by 2 power, say Lth root of 2. So here you just have to code the value I and the bit pattern for this, such that the value, when multiplied by that bit pattern, each bit represents one of these values, will become less than or equal to k. You will find you could be able to code a very, very large amount of information, like this. You can do simple ideas, tend to be very, very extremely effective. Okay, so for coding of information. Now This tells us that there is both a superficial and a surface truth of a thing, and the more deeper and the more profounder truth of it. That the seeming and the apparent truth of a thing on its surface and the real and the actual truth of it in its depths are two vastly different, radically opposite things. Thou shalt not judge a book by its cover. But ironically, this again does not mean that looks always lie and appearances are always deceptive. It does mean sometimes, in fact, you have to push past the surface, look beyond the exterior, separate and clean out and refine your knowledge and understanding, which is poor and filled with dross, into something which is more pure. But solutions do not automatically materialize and magically appear out of thin air. Pearls and diamonds do not float around on the surface. You have to probe and descend into greater depths. So if they have to be actively sought out and sought after by probing into deeper depths. But everyone loves a good treasure hunt, and knowledge, and even scientific and technical and artistic knowledge is always an inexhaustible treasure trove. So basically, the point of this particular exposition is, what I wanted to say in this particular video is that ideas can be verbalized. In the overall context of problem solving, some of the benefits and advantages verbalizing your ideas and thoughts confers upon you are, some of the benefits or advantages is, number one, it helps you to clarify your thoughts and your ideas. There is nothing more eye-opening and revelatory than explaining an idea to yourself. For starters, you will instantly be able to recognize it and to gauge its merit, its worth and its value, irrespective of whether you wish to go through with the idea or not. Second point is, an idea which is a brilliant flash of inspiration is much more of a beacon which beckons you and guides you than an actual one. A good idea can seize you and possess you and possibly also consume you, which is in my opinion not a bad thing. At any rate, it becomes either your immediate or ultimate objective or goal, and it invests you with a sense of purpose and a sense of urgency. It inspires, motivates, emboldens and empowers and helps you focus and fixate your efforts towards achieving that particular goal. In other words, it becomes like a goal in which to achieve. Thirdly, it helps you to always keep your goal in view and to never lose sight of it. Fourthly, it helps you to see things in the right and in the proper perspective. It acts like a compass and a direction finder. It aligns your vision with your objective and keeps you on track and in check. Okay. Now, also it helps you to make changes, alterations, improvements to your basic idea, that is bettering it and perfecting it and refining it and fine-tuning it in order to achieve the particular objective. Second, and then it also helps you to implement your ideas correctly without too much clutter, confusion. So you try to verbalize, express these as it helps you to implement your ideas correctly without too much clutter, confusion or error, somewhat methodically, systematically, clinically, with an extreme, almost surgical precision and accuracy. You will get it very precisely. It can point to and lead to other somewhat similar and related ideas, and it can also point to and lead to more general ideas and shine a light on more fundamental working principles. So if you know what are the underlying principles which actually drive or work the system, then if you do not misuse those principles, you can use the system to your advantage. If you misuse those and abuse those principles, because one, you are not aware of it, which is always the cause, more or less the cause, or you do not have a proper understanding of it. In either case, if you then the system will break down. It will not work for you. Either the system will break down or it will work against you. I illustrate and I demonstrate this truth with three simple ideas which provide excellent solution to the problem of information coding with the purpose of data compression. Now, if the first idea represents the body proper of the cake, the second idea represents the icing on the cake, and the third idea represents the cherry on the top. The first idea is take logarithm to a larger base and raise to the power of a smaller base. If you have b power L dash, there is something, say if you have b power L, the common this thing is map a number which is of a larger base to a binary base is a common request. There's a simple way is take log to the base b but raise to the power of 2. So this is nothing but 2 power log n to the base b is nothing but your code. Okay, so this is similar to coding a string or something. You can use this as a compact formula, right? How well you calculate or compute log is thing. Yeah. So this is a simple formula. You can, along similar lines, you can say take radix to a take larger index and raise to the power of a smaller index. So we have to map, say, 2 power L dash to 2 power L. Okay? Along similar lines, if we try and determine R such that R power L dash is equal to 2 power L, that gives us R is equal to 2 power L by L dash, right? Now your coding function will not be nothing but R power log of n, the number n which lies between 0 and 2 power L dash, to the base 2 log n to the base R. Now R is nothing but 2 power L dash by L dash. So you have 2 power L by L dash log of n to the base 2. Okay, 2 power log n to the base 2 is nothing but n itself. So 2 power n power L by L dash. Now this immediately suggests other ideas as well, right? All you need is a ratio between 0 and 1 here. L by L dash happens to work out perfectly. So would log L by log L dash, or L power something by L dash power something like that. So you can come up with better ratios here, right? Which will do the job for you. This is also a simple function which works. So a single idea can give different ideas there. Okay. So along similar lines, you can also try this out. This also works actually. Much more simpler idea. Multiply by a smaller divide by a larger quantity, but multiply by a smaller quantity, and subtract a larger quantity, but add a smaller quantity. Both of these also work. They may not give as much data compression as the case where you say raise to the power and decrease or take the log, but they will still yield significant compression. Some of them can be even used for perpetual hashing, endlessly coding more and more data in the same place. That can also be done. Now we look at the second idea, which is that code only the exponent, that this is a basic coding principle. Rather than code 2 power L dash, just code L dash. That is 2 power, there will exist values such that 2 power L V by S less than equal to something. And this will also give rise to other ideas, right? 2 power L dash log v plus 1 by log s, right? V cannot be 0, so we can assume this less than or equal to k. So basic idea, instead of code only either the exponent alone or code only the base alone, right? You can use any number of ways. Simple way would be, if you want to code the here, you put the binary representation here, half plus 1 by 4, 1 by whole power L dash, right? You can use you can factor 2 power L dash will remain m itself. You can factor this out and raise it to the power L dash. Or a much simpler way of this is 2 power L dash means if you have, you can use n, where L dash is equal to L, n is equal to L dash by L, sorry, C comparison ratios. Let's say n is, we have taken to be the value to be coded. Let's say C equal to L dash by L. Okay, you can take factor of 2 power L dash here and express this as power L dash. This is the binary bit pattern, half, 1 by 4 and so on. So or if you take this is also these, okay, you can either code the base alone or the exponent alone. That is one idea. And the third one is code the increment in the base, or sorry, code the increment in the exponent as a variation in the base, right? If a number lies between 2 power I and 2 power I plus 1, 2 power I less than n less than or equal to n less than 2 power I plus 1, right? 2 power I plus, find x such that 2 plus x whole power I is equal to 2 power I plus 1. That will give you x equal to 2 power I plus 1 by I minus 2. So you simply code it as 2 plus x times some value by s whole power I less than or equal to k. So this should also, right? The same thing can be done by increasing the value of the base also. You can have the same thing, which is, again, if you have b plus x power I equal to b power I plus 1, x will be equal to b power I plus 1 by I minus b. Okay, so this will be another idea is code the increment in base as a variation in the exponent, right? So if you have a number as which is less than b power L dash, right? There will exist a d such that d power L dash less than equal to n less than d plus 1 power L dash. So determine x such that d power L dash plus x is equal to d plus 1 power L dash. That gives you x is equal to L dash log of d plus 1 by d whole by log of d. Okay, so you know how to code the value. Value can be coded as d power l dash plus x times v by s less than or equal to n. Okay, so these are the things. So in all of these instances, we notice how an idea never exists in isolation but always comes with a lot of many similar and related ideas. This is always true of almost all scientific and artistic concepts and principles. They are never exist in isolation. Some of these ideas that we learn about set theory, logic, and probability theory, and permutation combinations, and all of these ideas, all of them are related to each other, and probability and distribution and statistics, they are all very much related to each other. Always exists in relationship to one another. In some cases, the relationship between the ideas is a complementary one, meaning which can be just as effective as the direct approach. The inverse approach can also be just as effective. In closing, as a final thought, I will conclude by reminding that all of the above techniques can be recursed. As a general rule, you see, if you can gain a little bit by using one direct method, by recursing it and breaking the problem down, and by recursing it and applying it into parts, you can gain a mile. So if you can gain an inch only by some technique, by recursing it, you can always gain a mile. So this way, for information coding, this law, you might say all these types of algorithms come under the class of, you could say, I suppose, as greedy algorithms, or where you try to code as much information as possible while cut down the size of the information as much as possible while increasing the size of the code by as little as possible.